All right, hello everybody. Hopefully everybody's having a great holiday. Going to run into today's lecture, which is totally optional and just a for fun topic if you were looking for something more graphics related to check out during your holiday weekend. If not, totally optional, and I'll just proceed this by saying if you don't watch this lecture, you won't be missing out on anything. And if you do watch it, that's great, and happy to answer questions about all things related to Vulkan via Piazza and keep up the discussion there. Okay, so with that, just wanted to note against some of these resources as we are approaching the end of the semester. I might have already shown this as a warm-up actually just to talk about Morgan McGuire and some of his work, but I wanted to just highlight again, these are some of the next texts that I would recommend, after this course, when we sort of wrap things up in another 2 weeks or so, if you can believe that. But these are just great texts going deeper into different topics. Real-time rendering, if you've really been enjoying the OpenGL stuff, if you really enjoyed the ray tracing stuff, to look at physically based rendering, or of course Peter Shirley's other books. So just something to keep in mind. And then on the mathematics side, the Graphics Codex is a really nice book that's sort of interactive and has different formulas, and I myself have a copy of this for the web. So just highly recommended resources for going further. So without further ado, moving forward, last lecture we talked about frame buffer objects. They can appear to be magic in some instances, this idea of rendering our scene to a texture. But it's actually a really powerful technique for doing different post-processing effects or capturing part of your scene or rendering your scene multiple times and sort of composing a more complex scene. So really fun, and powerful technique to learn about. And it's what a lot of modern sort of games and graphics engines do today to get high quality things. We looked at one example of Doom, for instance, in that lecture of how they just sort of compute different types of maps and then compose those into a final scene and do a little bit of post-processing in the kernel. There's an optional breakout activity, so hopefully you were able to participate in that and just get some ideas of different abstractions in game engines that are used. I'd recommend going and looking at some of those engines. The Unity one or Chord 3D, for instance, might be good ones to check out just because they lay out very nice, just a few short pages, how they think about their rendering architecture. So always worth taking advantage of work that somebody else has done to learn from, get some ideas as you think about perhaps structuring your own engine someday or building on the abstraction that we built in this course. Okay, so with that in mind, logistics, there's no lab today. Again, there's just a sort of lab 99, which is totally optional for fun. There's no credit, but if you do want to explore some other graphics APIs, this is a chance to do it. Otherwise, the main priority is to keep working on your homework, homework 6, and of course your final projects. We're really getting down to the final stretch here, where soon you'll be left with only your final projects remaining. Okay, so today, again, it's just an introduction to the future, so you know what else is going on in the graphics world. Totally optional if you want to proceed further from here, but it's always a good idea just to know what's going on. Okay, so what I would like to introduce is the Vulkan API, and that really is one of the future APIs. It's come out by the same, or developed by the same group known as Kronos, for doing graphics development. So Vulkan's sort of the low-level C graphics and compute API for doing more compute-heavy tasks and tasks that are typically related to OpenGL. It's, in a sense, a successor to OpenGL. I'll talk a little bit about that, but it's not necessarily a replacement of OpenGL. OpenGL will still be maintained. I could still foresee a future version of OpenGL coming out. There's certainly development on the WebGL versions, but Vulkan sort of serves a little bit of a different purpose. Okay, so what Vulkan's really for is, again, it's an API that'll run and help us develop graphics applications for Windows, Linux, as well as Mac. There's ways to use Vulkan on Mac. And again, it's seen as sort of a successor to OpenGL API, but I would say it's not a direct replacement. So, likely it's going to be the future API you'll want to learn. If you were to take this class, I would say 5 years from now, I would likely be doing it directly in Vulkan. I think all of our machines would have support for Vulkan. It would be sort of the right move to go. But that being said, I don't see OpenGL going away anytime in those next 5 years either. I still see, mainstream game developers using OpenGL, for various desktop. Maybe console gaming might be a little bit different, but I still foresee, lots of OpenGL games and graphics applications being built. The thing that Vulkan gives you is just a lot more control over the API. So in a sense, it's much more verbose, the API, meaning, we have to set up a little bit more. There's a little bit more boilerplate that we have to set up because we are determining exactly how our graphics API and the graphics pipeline works with Vulkan. Whereas OpenGL, we get to do a little bit of that with our shaders and sort of changing the state of things. But with Vulkan, we really have control over everything. Vulkan's really an API where the mission is to set up different pipelines for how you want to communicate with your GPU. Then it knows a little bit about graphics, and then that's about it for Vulkan. Okay, so I think that's one of the reasons OpenGL will likely live on for a while, because it just gives you a little bit more as far as features and those kind of things. Vulkan is much, much more low level. Okay, so what is Vulkan? Again, it's a cross-platform API. Most operating systems allow us to use Vulkan. Mac developers make it a little bit tougher. Using something called, you have to go through a sort of third-party library called MoltenVK to do Vulkan stuff, but largely my understanding is Vulkan is allowed to be used and totally fine. And one thing to consider with Vulkan is that it's a new library. It doesn't carry any of the legacy of other APIs. So it's brand new as of around 2016, 17, that kind of time frame, which is relatively new for a substantial API to be coming out. OpenGL, on the other hand, has been around since at least 1992. When we think about OpenGL 1.0, so that means it's carrying around a lot of legacy, supporting older ideas, older hardware, and how we sort of thought about things. So that's a nice advantage of Vulkan. So it is brand new. It doesn't have any notion of fixed pipeline. That stuff truly is deprecated in the Vulkan API. Okay, so with that in mind, the Vulkan API is thinking about modern architectures, leveraging concurrency, minimizing global states, understanding that you might have multiple CPUs and multiple GPUs that can do graphics work, which is much different than OpenGL, which just has this idea of having sort of one giant OpenGL context, which is giant state machine, which again makes things a little bit harder for concurrent programming. So with this in mind too, Vulkan also has some other advantages, meaning that it could be more energy efficient in how you divide up work and use your CPU. And when we're thinking about very compute heavy tasks, things even outside of graphics like machine learning, where there's just a lot of computation, Vulkan can be much more exciting to use if you have to mix a lot of computation with your graphics work. So really a key advantage with Vulkan. Okay. So how are we able to use Vulkan? What do you need to get started if you wanted? At least OpenGL 3.1, which again, most of our machines have and support. Most mobile devices probably aren't a good candidate right now. Again, that's why I would say, a few years from now, I will probably switch this course to, purely a Vulkan based course. It'll just be sort of necessary to do that. Then, or at least I'll then have confidence that everybody will have a machine that can support Vulkan or a mobile device or something. Okay. We do need to also, when using Vulkan, have a little bit more knowledge of GPU architecture. So understanding different mechanisms like what a semaphore is. We can talk about things like fences. And sort of making sure that memory has a chance to synchronize, because our GPUs are very much machines that you throw a lot of data at, and they sort of crunch things without any synchronization. But every once in a while they have to sync up. So those are some things we have to think about Vulkan, and we can use semaphores to coordinate tasks. Okay. Now, again, I'm sort of giving you the quick preview today about Vulkan, just as sort of a bonus topic. But again, if you're going to go on and be a graphics engine programmer, you probably will want to learn Vulkan. I can see a lot of engines or have been watching sort of engines like Unity 3D or the Epic's Unreal Engine start to have support for Vulkan and hear about the ports that these engines are going through. So definitely something you will want to pick up eventually. Just like I'd recommend folks eventually look at DirectX 12 if you're on sort of the Windows side as well, just to broaden your sort of graphics API knowledge. So again, not a future predictor, but I have a good idea of the sort of industry pulse on some of these things. I'd say around 2025, Vulkan's going to be quite popular and perhaps the default API when you look for programming tutorials in graphics. I could see that from about 5 years. So again, should I use Vulkan or OpenGL? It depends on your needs and what you're building. And I think this picture on the right sort of summarizes things quite nicely. So starting with OpenGL, which we're familiar with on the left side, this is what we're given. We're trying to write an application, and we get this huge sort of API that includes things, all the OpenGL stuff we can do, the giant OpenGL context, some different debugging tools. It sort of handles errors and is managing states. And it gives us all this functionality in this sort of huge collection of things. We get all these different OpenGL functions that we can do. Okay, so that's what OpenGL gets us. And on the right side, though, the application that we write, so that's this green box, we're responsible for doing a lot more stuff just by the scale of this box compared to over here. We have to allocate our own memory, manage our own threads, generate our own buffers, and all these different things are what we're responsible for in our C and C++ code that we write in Vulkan. And then the stuff that we get for free, that's the driver here, or the sort of API here. OpenGL, remember, we get a lot of stuff for free on this side, but Vulkan, we just get a little bit, we just know how to sort of talk to and pass information back and forth to our GPU. It's just sort of the minimum subset of things needed to coordinate with our GPU, how we're sending back and forth data. So that's sort of the main difference with Vulkan versus OpenGL. Where do you want the responsibility to lie? Well, if you want a lot of control and to do everything your way, Vulkan's a great API for that. And that's really its intention. So if you are really building a game engine or something from scratch and need to know how every nitty-gritty detail works and squeeze out every ounce of performance, you want to have a lot of this control. And then just have a really thin layer here, the driver that talks to or sort of responsible for passing information back and forth between your GPU and CPU. That can just be a really small layer here. Okay. So that puts you in charge. You have to do most of the stuff when you are working in Vulkan versus OpenGL. Even though in reality it seems like we've really done a lot of stuff to get set up, Vulkan just requires a lot more boilerplate. Okay. So some other notes, if you're going to write an application, and this might be something that you consider, or a company that you work for, and you need to support a lot of users or a wide range of systems, again, OpenGL is probably going to be just fine for you. Okay. If you're working on newer systems and can take advantage of things like concurrency, multiple CPUs, multiple GPUs, Vulkan's where you're really going to start to get some advantages. And for now, the easier to use API is probably OpenGL. Okay. Again, it's just a little bit more high level, even though it might not seem like it, right? It took us, a week or two just to get some, shapes rendering, but, for Vulkan, it would be the same process, but we have just more setup to do. Okay, it's actually worth looking at. If I might just Google for a moment, Vulkan, hello world. And Vulkan tutorial is a great site for this. This is the equivalent of our Learn OpenGL. We have all the same stuff. We have shaders that we need to write, so the OpenGL stuff that we've learned has been fine. But I believe if I kind of scroll around here to drawing a triangle, they've got a pretty decent setup here. I'm just trying to see if I can find a full code sample. And it doesn't look like they have anything laid out, but I just want to, sort of observe some of these things where we're doing all these things like, setting up the context for a specific context in Vulkan, the application information, all these different things that we have to set up that are just very powerful in a way because we get access to all of them. But again, it's more work for us, right? We've never had to query how many devices we have and what sort of abilities they have, and sort of look through them and set any of our device properties. So, we get a lot more control, but again, this is just a lot more boilerplate. Again, you can see I'm just highlighting on the left side here how much work is needed to, draw a triangle here versus, realistically in the Learn OpenGL, that's only one, page tutorial. This is, several pages. So is it harder? Maybe, we have to understand a little bit more, which is also fine, to understand more. It gives us more insight into how the GPU and our CPUs work, but again, it's just a little bit more boilerplate. Okay, so just wanted to highlight that. Okay, so again, it's not that it's difficult, it's just new and we have a little bit more control, so it's a lot more setup. So we have to be just a little bit more patient with Vulkan. Okay, so looking at Vulkan, here's the things we can do. Here's sort of our huge pipeline here. And of course, you don't need to look at all of this. Just like with OpenGL, we didn't look at all of it at once. We kind of broke it down into the different stages. And you can see some of these things are familiar. Like the orange box here is a vertex shader, and that's something that we can program here. Here's another orange box for a compute shader. There's tessellation shaders, geometry shaders, which we'll learn about, and fragment shaders. So some familiar things here that we can program here. Okay, so the Vulkan pipeline. So we sort of get to build this though, the actual Vulkan pipeline here. So how do we do that? Well, we have this object here called VK pipeline, which is sort of this monolithic object that contains everything. All of the shaders are together, information about our layouts, any state information that we have. And what's really powerful about this is that this is one just object here that we're working with, a VK pipeline. You can think of it like it's its own class that you're working in. And you just kind of compile it once and pass this to the Vulkan driver, and then you sort of have that pipeline set up and ready for you to go. Okay. Okay, so some important pieces of the pipeline here is something called a command buffer. So in OpenGL, we're sort of doing this immediate mode fashion rendering here, where we're doing things like GL clear color, and that immediately sets a state, and then GL clear, and that clears stuff up, or GL draw arrays, which requests that we draw something. So while we're doing this, the driver in OpenGL sort of guesses how much work to do. After it's been running and it sees these commands, it has to sort of switch states, which can be expensive. But in Vulkan, our model is a little bit different in the sense that we sort of build a pipeline of commands in these things called command buffers that we're going to send to the GPU back and forth. And since we sort of built these command buffers up, the hardware can do a better job of anticipating, what work is it going to do, what order should it do it, does it know some sort of draw call is coming, and it can sort of work a little bit more efficiently. If you've taken a compilers course, for instance, compilers do this a lot, or even our hardware, where if you can anticipate what the next instruction is going to be, let's say it's cached, then you could do things much quicker. So in Vulkan, again, since we're working with objects and things that could be potentially cached or sort of have a look ahead and see what's coming, our driver can be much more efficient. So our driver, again, is that thing that communicates between the CPU and GPU and does some work on the graphics card. So we get that advantage in Vulkan. So the command buffer resource advantage, again, is this idea that so everything's going in these little command buffers for different things that we want to do. And we can have them running on different threads because we can sort of package up everything nicely into this set of commands that we want to do. Versus OpenGL, we're sort of stuck with, we can have multiple threads doing work on data, but as far as our graphics work, everything, is going through this one monolithic OpenGL context object. Okay, so we're usually stuck to sort of a single thread of performance there. With Vulkan, now we can have multiple threads, so it's a lot more powerful in that sense. Okay, so there's different types of command buffers. Just like we had many different buffers, vertex buffers, index buffers, and so on. On OpenGL, in Vulkan, we have different types of command buffers. Okay, so there's ones for transferring data back and forth, compute, doing stuff with frame buffer objects, and many more. Okay, this last one, render pass, I'll just highlight because it's sort of fresh in our mind from doing the frame buffer object, but this is a similar idea to the frame buffer object with the idea that we can sort of encapsulate or sort of capture all the drawing tasks that we want to do into one object. So we sort of have these a render pass. Okay, so this might be the different things that we would want to do some drawing, maybe another pass, do some more drawing, and so on. And this is, again, very similar to how we sort of bind to different frame buffers, do some drawing, capture that information, maybe bind to another frame buffer, redraw our entire scene or that entire object, and render it in a different way, and then sort of save it to a texture like we did, and then draw it to the texture. We can encapsulate that, or we have that same idea with these render passes in Vulkan. Okay, so there's an actual object for sort of allowing us to do that. In Vulkan, we still write shaders, same kind that we did before. So you can look at a little introduction on what that means. SPIR-V is just sort of the assembly language that shaders compile down into. That's what Vulkan uses, so we can, again, take advantage of our OpenGL that we have learned, which is wonderful. Again, we just sort of lay things out in a shader. We have something called a sort of descriptor layout in our pipeline. This is sort of similar to what we were doing in OpenGL shaders anyway, where we sort of say what the layout is, what our uniforms are, etc. We do the same thing in Vulkan, and then compile our shaders down into some sort of binary object that's sent over to the GPU to run at particular stages in our graphics pipeline. Now, because we are writing what's called a SPIR-V shader, the standard portable intermediate representation, if you happen to know DirectX, which uses HLSL, the high-level shading language, or if you know OpenGL, or if you make up some other language that you want to write shaders in, you can compile them all down to these SPIR-V shaders, which is kind of cool. So you can use whatever shading language you want, which is a really nice feature of Vulkan. Learning some other tool doesn't hurt you. It only helps you, and you can reuse that in Vulkan, which is super, super nice. Okay, so for Vulkan, for our first triangle, again, just going back to that Vulkan tutorial, really a nice website. It's actually come a long way. Every time I talk about Vulkan, this tutorial has gotten better and better, like the Learn OpenGL stuff. So really nice explanations for getting started with Windows, Linux, or Mac for folks if you do want to check that out. The other good resource is the LunarG SDK site, which I believe recently they've become sort of the official resource on this. So super cool stuff to check out as well if you just want to see some of these different things, like what a render pass is, shaders, working with frame buffers, and so on in Vulkan. Okay. Now the trouble is, or why I'm not going deep into this through the slideshow, is because it's about 700 lines to set things up. There's a nice, here's the actual resource I should have shown on just getting set up in Vulkan, and here's sort of the setup code here for our first triangle. You can see I'm just scrolling through it quick, but this is the pseudocode of an application. So it's not everything, but it gives you a good sense of just how to set up a Vulkan application. And again, you'll notice it's quite a bit of setup, which you shouldn't be scared of, but if you're gonna sit down and work through it, just be aware of that. But once you set it up once, you're sort of good to go here. Okay. So again, a few more key ideas about Vulkan. Just trying to keep this a little bit shorter here, but multi-threading, synchronization, these sort of things are huge ideas in Vulkan. They're where we get a lot of our additional performance from, and that's something that we can't really get in OpenGL. So this is why Vulkan really matters. Another thing that's really cool about Vulkan is it does a better job with error handling. So the Vulkan drivers themselves don't handle errors like we were trying to do in OpenGL anytime we do a GL get error or something like that. But instead we can add these sort of validation layers that check to see if an error has happened somewhere in our pipeline. And we can turn these on and off, which is great for performance. So you can sort of have your release build of software that doesn't do any error checking and runs super fast. But when you're developing Vulkan applications, you can turn on these validation layers, which is super, super cool. Again, you don't have to have all this additional overhead. Okay, so some Vulkan examples. This is a fun YouTube video. Check it out. I'll just highlight at the bottom. You can see the performance here. So running an OpenGL on the left versus Vulkan on the right, just how busy your CPU is. You can see there's a lot better utilization, meaning it's being used much more efficiently here. On Vulkan, because you can spread the work over multiple cores. So again, much more energy efficient, same performance. This is a cool example where they sort of go through, again, on the left side's OpenGL, on the right side's Vulkan, sort of show off some metrics. And this is actually in Unity 3D, a popular game engine for doing game development. And again, you can just see Vulkan allows you to do all the same things, yet you can do them a little bit more efficiently if you have some more modern hardware. Let's see. So Stephanie Hurlbert is an expert in graphics programming. I believe she was at MIT and also does some commercial and other game development stuff. A while ago, I caught this, I believe on Twitter, she found or called out for a bunch of beginner-friendly Vulkan tutorials if you'd like to look for more, so I thought this was helpful to put in here. Okay, so some final Vulkan perceptions. It's more lines of code than OpenGL. That's probably true. There's more boilerplates and things like that to set up, right? We have to do all the same sort of SDL stuff, plus all the Vulkan setup. But, in a way, it's actually a good API design. If you can sort of front load a lot of that work in your application on the setup and have a lot of control over, how exactly you want things to be done, so it can be a good thing. It makes it harder than OpenGL because it's a little bit of a paradigm shift because we're thinking about how to sort of break up work and send it over to the GPU. So not 100% ideal for, learning graphics for the first time, but now that you guys have seen and worked in OpenGL in a little bit, it makes Vulkan a sort of more natural next step to take, which is great, okay? And I'd say generally you need a little bit more hardware knowledge with Vulkan, thinking about things like concurrency and just really think about the work that your GPU is doing and, what it means to be compiling things and some of these ideas. So a little bit more knowledge, but everybody in this course is prepared to take on Vulkan. Okay, so with that said, there's a little in-class activity if you want. It's just a quick form to fill out. I'll leave it sort of at the break here, and then you have the chance, totally optional today, if you want to explore a graphics API, feel free to dive in. It's not required. But otherwise, I will see folks for office hours and look forward to checking in with you then. So feel free to sign up for an office hour and check in with me. And then hope everyone had a great long holiday. And, we're almost there to the grand finale. And really looking forward to seeing folks' projects super, super soon. All right, take care, everybody, and we'll talk to you again soon.